Thank you very much for coming. I'm going to present on DAOs and DeFi. We're going to talk a little bit about DAOs, or an idea that I had for a DAO for the XRPL. And then we're going to jump into some DeFi. I'm going to explain a little bit, and then we're going to do a demo of some actual DeFi products. We do a lot of talking about it, but let's actually see it implemented on the blockchain. So what is a DAO? A DAO is a blockchain-based community-run organization with decentralized decision-making. So the idea that I had for a DAO was sort of a core ledger-specific DAO. So the governance would be done by admin members chosen maybe by validators or just high community profile people. But the main point is that there's sort of three aspects to it, and that's candidates who are developers vetted by admin or community members. So that's Ripple reviewers, Ripple maintainers, etc. And then you have sort of this request aspect, which is requests for information. So not everyone knows how to build a profile for a new amendment on the ledger. So you could just put in a request for information, and you could talk about the proposal. And then once discussions have occurred, you could move to sort of a request for proposal. And then someone with the expertise, like Mayuka, me, or anyone else who's written proposals, vet, etc., could write a professionally done proposal. And that would then sort of move to the proposal stage. And there we would see sort of requests for quotes. So people, developers, the candidates, could then put in a quote to finish that work, complete that work, and there'd be steps involved with that. So then reviewers would review the code, and you may have to put in another quote, and then finally, once it was fully reviewed, it would be paid out. And that would all be decentralized. Currently, obviously, I am a very big fan of hooks, so that is currently written in a hook, but we're not going to demo that today because I'm not sure I have enough time. But that was sort of my idea for sort of a core ledger DAO. When we think about DAOs, that's really only one aspect. I would call that proposals. When you think of a DAO, there's so many levels to an organization. To make that completely decentralized and automated is a huge task. And it's something that I started going into and found sort of a rabbit hole. So I wanted to just focus sort of on that proposals aspect. So we are going to switch topics back over to DeFi. So the first one we're going to talk about is a bond. And a bond is a loan to a borrower that pays interest and returns principal at maturity. Some of the things I'm just going to highlight what I think we could sort of rewrite onto the protocol level. So the first aspect of a bond, or the first thing that happens, is a request for proposals. Issuers don't actually sell bonds, underwriters sell bonds. So the underwriters put in a proposal to sell the bond, and they receive a discount for that. So the underwriter says, I'm going to sell 100,000 bonds for you at a 10% discount. Another aspect that I think we could rewrite is the coupon rate. And then there's that return of maturity, or the return of principal at maturity. And then the fourth one here is that most bonds are actually sold OTC and not on a DEX. So I don't think it's a good fit for a bond to be an issued currency, because if an underwriter if they're negotiating a sale of a large quantity of that, and that goes on a decentralized exchange, then somebody else can swipe in and take that. So I would prefer to write them as non-fungible tokens, where the offers have a destination. So they can make that negotiation outside, and then that transaction can occur on the chain. If you don't do that, then basically you're back at this trust where you send me the money first, and then I'll send you back the assets. So as a DeFi smart contract, there's 4 components: the offering contract, which includes the offering details, the bond details, as we talked about, the underwriting referral codes, and the discount percentages. In this case, the actual issuer is minting the bond, and it's done as sort of a just-in-time minting. And then I would make would make a few changes where you bulk mint tokens out. So if I wanted to buy 100 or 1,000, you could bulk mint them. The third contract is a claim contract, which records and pays out the coupon payment. And then the fourth one is a maturity contract, which basically records and pays out the principal at maturity. So now we are going to take a look at what that would look like on an actual blockchain. First, we're going to set the hook. I'm not going to really explain this one. Then the second thing we're going to do is create the bond offer. And that is going to sort of take us a few seconds here, but we can see the transaction was submitted. And then we're sort of walking the ledger along on purpose to simulate time. So it's sort of, something hacky I have to do if I want to show this. This is the bond here. I'm going to go quick because we are technically on a timer on this. So now we're going to mint the bond, and then once I set this, I can just go back and explain. So this is the bond model, and this is actually sort of a hex bytecode that's compiled in and then stored in state inside of the hook. And this actually allows us to have dynamic NFTs using hooks right out of the gate. So you could see all of the details on the bond, the asset, the coupon frequency, the maturity date, the call type, and then some counter and a status. So right now the ledger is walking along to simulate because a bond pays a coupon every month or semi-annually. So I'm just simulating that here. But here you can see that coupon was returned. The bond here is 2,000 is the principal, and the coupon is 2%, paid for 12 months. So that calculation is 3.33 every month. That's a simulation of what a month just occurred. So that bond pays it out, and then we're going to mature the bond, and we're going to watch it send the money back out of the smart contract back to the user. So again, we're simulating time. This is sort of a construct that I have to deal with when doing this. When the bond is minted, I went over that really fast. When the bond is minted, you receive a URI token. So you own a token you can transfer that on any sort of protocol that NFTs would allow the transfer of. And again, that metadata of the bond is stored in state. So we're still gonna walk it along, and then it should return the principal or the principal, so the 2,000 should return back to the user. And if you're not familiar, I realize I'm jumping way advanced, but if you're not familiar with the way hooks work, you invoke the smart contract and then an emitted transaction occurs. And so this is the invocation of it, and this is then the emitted transaction, and the 2,000 is then returned back to the user. So that all happened on chain. There was no database. There was no, I didn't have to trust any intermediary to do that. The only thing I guess you would have to trust is that the issuer of the bond has the coupon payments in their account and or the maturity once it matures. So there are some issues with this structure. And I think this one highlights some other big issues. Scalability. And this actually affects distributions, as we're talking about here, coupon payments and maturity, and voting in general. So like the idea of a DAO where people vote. If we don't use a quantity on the bond, making 100,000 coupon payments or distribution payments is super exhaustive to the ledger. So I think that's an issue we actually need to solve altogether, no matter what. I have some ideas. One of them would maybe be bulking the transactions together. So instead of 100 or instead of 1,000 different transactions going out, it's one transactor on XRPL and then adjusting 1,000 different accounts. Another issue is fees. Smart contracts do cost a little bit more money. That's just something that happens with smart contracts. It's not an exceptional amount. It's not close to Ethereum. It's okay, and it's very small. But it's important to note that a smart contract can be written at the protocol level to reduce the fees. Another thing that I would say is an issue with this is coupon and maturity. The way I did payments there is that the user reaches out to the hook, and then the hook sends the money back. And as I said, that could go the other way, where issuers want to send the distributions out. So that's sort of an issue with the way I did this. And then finally would be fractionalization. If you're familiar with the stock market or high level stuff, Most of that is sold in lots, in 1,000-lot chunks to big institutions. So what I would do if it were me, like I ran the NASDAQ, is I would actually put a middle side chain between the protocol level at an institution level and the end user, like someone on Robinhood. So I would take that bond, lock it up, and then reissue it at a fractionalized level between the user and the protocol level. And I think that would be a better approach, so that at the protocol level, we can still send out the coupon and maturity and then let the intermediary distribute that or fractionalize that. It's not really how a lot of people think about it, but that's an idea that I think would be interesting. So options are the next DeFi product. Not a lot of people are talking about options being tokenized. We hear a lot about real estate and other things. So an option is a very advanced stock security investment vehicle. An option is a contract giving the right to buy or sell an asset at a set price by a specific date. They are confusing, so I'll try to go slow. But some things to note, again, that we could write onto the smart contract or the protocol level. Options are listed by the CBOE with a strike price and an expiration. Investors open positions. It is a two-sided contract. So someone is writing the contract and someone is buying or agreeing to buy the contract. And then open interest would be because it's two-sided. So if I said I want to write a contract and nobody had bought that contract, or what I like to use the term called sealed that contract, then that would be considered open interest, that one side of the contract. Options are exercised in three different ways. You can execute the contract. In America or in the US, you can exercise any time or execute any time between the day you bought it and the expiration date. In the UK, I believe you have to do it on the expiration date, but there's two different types. So you can also close a position. This is a little more advanced. I'll get into that later. Or you can just let it expire if it's not in the money, which is a term they use. If you had a strike price at 20 and the price of the stock was at 18, there's no reason to execute anything, so you just let it expire. So I'm gonna explain option calls. So again, we have two sides. So the buyer, the holder, has the right to buy an asset at a strike price, and they pay the premium. The other side, the seller, has the obligation to sell the asset at a strike price. Obligation is really important here because that means that the seller must deliver the asset to the user, which means that the seller has to have that asset. We're not going to do, there's a term called uncovered calls where the seller can write a call without actually owning the underlying asset. All of this, what we're doing, the seller has to have the asset. So what we're going to do is we're going to lock it up so that we know in sort of an escrow type of situation, so that we know the user is not going to turn around and sell that before the expiration. And then the seller would set the premium that they want to receive for that. I wrote a protocol amendment for this. It's called XLS 62. There's three different transactors. The first one is listing the option, so the strike price and the expiration. The options are listed under the issuer. The lister would pay the reserve, and they can be removed after expiration. The second one is option create. This is sort of the main one. You include the option ID, the premium, and the quantity, the type, which is a call or a put, the action, which is buy or sell, and then the position, which is open or close. And then finally, the exercise of the option. If you wanted to execute, so for example, if I had a GME GameStop and I wrote a call for 100 shares of GameStop at 20, and we're going to assume I'm in the money, the buyer would receive the shares and the writer would receive the quantity times the strike price. So the buyer, when they buy the contract, they pay the premium for the right to later purchase. So at the end of when they exercise it, they still have to pay for all those shares. The offers are removed. Closing a position is a little more complicated. In that same example, if I wrote a call for 100 at 20, closing the position actually means opening the opposite position. This is confusing for a lot of people. Basically, if I wrote that call and somebody sealed that option with me, I would then turn around and buy a call, which would somebody else would have written the other side of that. And basically, when I did that, it would swap. So I would no longer be connected or sealed with this, and this person and that person would be sealed. So it's a weird way, if you think of escrows where there's two parties in an escrow, it's sort of flipping them and matching them. I know that's confusing, and I wish I could explain it better. But we're gonna demo it. We're not gonna do the closing of a position because that's very confusing, but we are gonna demo a basic option. So we're gonna restart our standalone environment. We're gonna give a second for the Explorer to come back up so we can view our transactions. Perfect. All right. So first, we're going to list the option. That just listed the option. You can see the bottom here is the actual object on the ledger. So we have the expiration in Ripple time, and we have a strike price, which is at USD. We're not doing strike prices or premiums in XRP because that asset fluctuates, and so that would be sort of a derivative on a derivative. So I like the idea of it being in USD. Now it does open the door to like now some of them can be in Euro or RL USD, but that's not really a problem I'm gonna solve. So the next one is now the user selling the call. And so if we go back over here, what we're gonna look for is in the metadata, got time, we're going to see that the state for the balance of that seller now locked up 100 of the GME stock. So it's locked up, they can't sell it. That's all that the seller needs to do, so we can verify now that that seller is not going to sort of break its terms. Now, the other side is going to buy that call. There's also some features here. You can see the quantity here and the open interest. So as I said, that contract's not sealed yet. So there is 100 open interest. The rest of the data's on there. You can see the premium up here. So now we're going to buy the call. And so now we have two open offers. That's our first one. This is our second one. We can now see that the open interest is 0 because those two have been sealed. We can also see, I call it the swap ID, but this swap ID here matches the index of the other offer, and the other index here matches the swap ID of the offer. So these two are connected, or what I like to call sealed. So now if we go back to the Explorer, we should be able to see that this user paid the premium for that. So change of Ripple state should be positive 50. So this is the writer. So the writer received 50, and if you're wondering why it's not 0.05 times, or why it's not 0.05, it's the premium times the quantity that you're expecting to purchase. So that looks good. I could verify that it's on the other side, but that's not that important. And then finally, we're going to exercise. And this is sort of where the magic happens in an option. And so now we can see there are no more offers left, right? The offers down here are empty. And if we go and we review our final transaction, we can see that everything should have occurred perfectly. So now we could see, now negative 100 is just a term in Ripple, but this is the buyer's account. So the buyer now has 100 of the GME. So they exercised the contract and they received those shares. Let's see who this is. This is the seller. So the seller received the quantity times the strike price. So 20 was the strike price and the quantity was 100. So they received that from the buyer. And then we should be able to verify that so here the locked balance was 100, and now we have no locked balance, and the balance was reduced by 100. So again, all that happened on chain. That was options happening without a server, without a central database, 100% on chain. There's a few more things I need to do before I PR it. One of the big things to get this into Ripple D would be the fact that we could lock up an IOU token that currently doesn't exist right now. So this wouldn't be able to happen on Ripple mainnet, but it could happen somewhere else. The other thing is that there's sort of this new idea or concept of the multi-purpose token, and this does allow us to lock up or escrow funds, and so that is likely what I would use in if we were going to get this merged into Ripple D. That is everything. So thank you very much.